The building on the right is a completed project. We're going to go through about 5 modules, I believe it is, to complete this project. And each week we're going to, or each module, we're going to actually build the technical components that go into creating a real building. And so I want to take some time to kind of explain that componentry and give you some real world examples of how they exist. In this module, we're going to work with grids and levels. We're going to learn how to place our objects. We're going to then come and place these steel beams, and we're going to have footer elements, things that are going to support all of our mechanical, or excuse me, all of our structural elements here. So I really want to take a few minutes and kind of explain how these structural elements are commonly used in architecture. And here's an example of the project that we're working through. This I found in downtown Buffalo a couple of years after we started this project, and I thought it was very close or very similar to what we're doing, so I thought it would be interesting to show you. It's a brick building with that idea of columns. It looks like it has approximately 20 foot of spacing between the columns. So it's not an atypical, it's a very typical type of construction. This happens to be what will be a co-working space. And I'll show you it completed here. I'll go forward to, this is it completed. Has an awning on it. We'll be constructing an awning. We'll be putting some graphics on our building. So we'll be starting to learn the basic techniques of doing all the kinds of details that go into real architectural projects. So let me go back, and what might not be apparent to you looking at this building on the left side here is that this is curtain wall construction. And by curtain wall construction, I mean that the wall assemblies, the outside facade of the building, is actually being attached to the floors and the roof and not supporting them. They're hung kind of like a curtain would be off of a curtain rod, except in this case it's either the floor or the roof. And so this is the framing of it. It's made with metal studs, as opposed to wooden ones that we commonly see when we see a house being built. And here's maybe a better example of how that all of that structure is working to support the floors and the roof. Now we have no facade, and yet the roof and the floors are being held up. This is another example down the street of this idea of curtain walls. I think it's important to understand curtain walls in general, just because it solves the problem of understanding how structural relates to commercial buildings. It frees up the facade from having to carry that weight. And it's an intellectually good place for you to start when we're talking about commercial buildings. So here we have, once again, floor systems already supported by the internal structure of the building, and the facade being hung on the exterior of the building. In our case, once again, we're going to do a 20 foot by 20 foot module. I picked 20 foot by 20 foot because it's a common span. If we went larger than that, it would be the size of the structural components would become inordinately large. Here's just an example. We start with constructing our foundation system. It has a footer below it, that widened area. And when we draw the wall first and add the footer last or second, and that's because the footer uses the wall to reference it. But in reality, we pour the footer first. So this is an example of footers. They're a spreading of a pad of the concrete, kind of to bear the weight of what will be placed upon them over a larger area of soil. And in this case, these pads have rebar sticking out of them, reinforcing steel, and a concrete column will be poured above this and that column's weight will bear on this footer. This is a real world, in my neighborhood on Elmwood in the city of Buffalo, building going up, a commercial building. And inside here, these are really large pads that are going to support the steel columns. We're going to make much smaller pads for our building. But this had an unusual requirement for structural. But the important part of this image is where you can see the gentleman bending over here. That is, the pouring of the footer is been already completed. It has a wet look to it. It's wet concrete, just freshly poured. And you can see this rebar, this metal reinforcing sticking up. And that's going to be contained within the formwork that goes around here before they pour the wall that the building will be supported upon. Here's a cruder look at a footer. Footers don't have to be precise because they're really just They're just creating the starting pad for the wall. It's important that the wall's aligned, but the footers can have a little bit of this kind of jogging or whatever with it. Moving on to steel. Once again, another image of something very typical to what we're doing. We're going to put steel framing up. It happens with the click of the button in our software. We just make a few choices of the kind of steel we want to use. And here's an example of that. And I have another example. So here we have what are called wide flange structural elements. And by wide flange, and you'll notice this is still on module. It almost looks like an identical idea, 20 foot on module, and with these large steel beams going across. It's important to know about this idea of wide flange because I actually ask you to select a component that is a wide flange beam. And the difference of a wide flange is this lack of taper of what would be sometimes called in general terms an I-beam. But these are wide flange beams that we use when we're talking about architectural structural components. That's so here we have in this chart that I put a snippet on, we have this W27 by 178. It's important that you learn early on that the 27 is the depth of the beam and the 178 is how much it weighs per foot. So if we have a W27 by 84 pounds per foot and it's not strong enough to carry the load, one of the ways we can make the beam stronger is to add steel to it, make it heavier. And so we have all of these choices going up to the heaviest beam that's probably made, which is the W27 by 78. And the reason we might want to add metal instead of the depth is we might be limited on how thick we can make the floor or roof section. So there's some other components that's going to be coming forward in the next module after that. We're going to start adding the glazing and some other building components. So I want to take a few minutes and describe those also. And I'll break the video up and I'll actually pick up on that next.